Well, we've been talking about two-dimensional figures, and now we're going to expand our reach, uh, where we're not just talking about whether they're concave or convex and um, that kind of information, but now we're looking at perimeter and circumference of triangles, squares, rectangles, and circles. And so here in this key concept box, we see that, let's start over here with the triangle. So if we're trying to find the perimeter of a triangle, well, it is just we're just adding the measures of the sides that we have. And the same thing is true if we have a square. It's side plus side plus side plus side, or 4 times s. In a square, all of the sides are going to be equilateral. We also can identify that it is a quadrilateral, gives us other indications where we see that each of the angles are 90-degree angles, as is also the case with a rectangle. However, the perimeter of a rectangle is the length plus the width plus the length plus the width, or we could say it's 2 times the length plus 2 times the width. And then a circle is different. If we're talking about the perimeter of a circle, then that is the circumference. And so the circumference is 2 pi r, or 2 pi, the diameter, 2 pi r being the radius, or pi times the diameter is going to give us the circumference, or the perimeter, we could say, of a circle. Now the area is a little bit different. In a triangle, it is 1/2 the base times the height. In a square, since all the squares are the same, they are equilateral, they're the same length, it is just the side squared, or side times side. With a rectangle, the area is the length times the width. And if we're finding the area of a circle, it is pi times the radius squared. Now we're going to take a look at a few two-dimensional figures, and we're being asked to find the perimeter or the circumference and the area of, I think I've got 3 two-dimensional figures. This corresponds to page 58 in the textbook. Example 2, we're being asked to find perimeter and area. So let's do a little calculating. Well, let's do a little calculating as promised on perimeter or circumference and the area of two-dimensional figures. And let's look first at the one we have here on the left. Well, I know that it is a quadrilateral. I've got 4 sides. I know that it must be a rectangle for 2 reasons. One, every angle is 90 degrees, but the side lengths are slightly different. And so the perimeter of a rectangle is the length times the width, length plus the width plus the length plus the width, or 2 times the length plus 2 times the width, or I could write it like this, 2 times, in this case, 6 plus 5.5. That would be 2 times the length, 2 times the width. And let's see, that would be 2 times 11.5, 6 plus 5.5, and 2 times 11.5. So the perimeter of this rectangle is going to be 23 feet. Now, if I'm going to find the area, well, the area is just going to be the length times the width. So this is 6 times 5.5. It's going to give me the area. And let's see. 6 times 5.5, I can actually do that in my head. 6 times 0.5 is 0. Carry your 3, 30, 33. So it is going to be 33, and this is important, using your unit of measurement, square feet. So 33 square feet. All right, now let's look at the circle. Now, we know that the circumference can either be, we can either use 2 pi r, or the circumference can be defined as pi times the diameter. And I'm going to choose this because I can see here that this 6.2 centimeters is the diameter of that circle. Now let me get my calculator out because I'm not going to be able to calculate that one in my head. But I've got pi times 6.2 centimeters. And I'm going to round this to the nearest tenth, I guess. And that's going to be 19. Where'd my pencil go? Okay. So we got pi times 6.2. And that's going to, the circumference is going to be 19.5 centimeters. Now, what about the area? Well, the area is pi r squared. So I'm going to have to do a little bit of something different here. I'm going to need to find the radius. R is the radius. Well, that's half the diameter. So half of 6.2 would be 3.1. And so the area of this circle is going to be pi times 3.1 centimeters squared. And again, I'm going to get my calculator out to determine this. Let's see, there's pi times 3.1 squared. And that is going to equal, after rounding to the nearest tenth, 30.2 centimeters squared. Refer back to your charts until you memorize these formulas. We're going to look at one more. We're going to do a triangle next. So we're finding perimeter and area, and now we're looking at a triangle. And so let's start with the perimeter. Well, the perimeter is just the measure of the sides added together. So here we got the perimeter of this triangle then is going to equal 9.5 plus 9.5 plus 10.2. Let's see, 9.5 plus 9.5 is 19. And then 19 plus 10.2, so my perimeter must be 29.2 inches. All right, not too bad. Now, area is equal to 1/2 the base times the height. And here, this 10.2 inches is my base, and I see my height given here as 8 inches. From the base up to this vertex right here. And so all I'm going to do is just plug this in. So we got area equals 1/2 times the base, which is 10.2, times the height, which is 8. And I think I will get my calculator out on this one. All right, so I got 1/2, or I could say 0.5, times 10.2 times 8, the height, enter. And so my area then is 40.8, my unit of measurements inches squared, 40.8 inches squared. All right, this is actually something you can use.